a particle moves from point, so this point to this point. Okay, a particle moves from a point minus 2 I cap plus 5 j cap to 4 j cap plus 3 k cap when a force of 4 I cap plus 3 j cap newtons is applied. How much work has been done by the force? So this is very simple. Okay, so work done is equal to what? Dot product of force with displacement. So force is given, F bar is equal to 4 I cap plus 3 j cap. And what is displacement? So this is initial position vector, this is final position vector. So what is displacement? Final position minus the initial position. Okay, so displacement r bar, or let's call it delta r bar, it is equal to r2 bar minus r1 bar, and this is r2 bar, this is r1 bar. Okay, so this is 4j plus 3k minus 2i plus 5j. So what will be result? So there is no x component in this. Okay, so this minus minus becomes plus, so you have 2 I cap, then plus how many j cap? So minus 5 j cap, and here you have 4 j cap. So 4 minus 5, so minus j cap, okay, and plus 3k cap, plus 3k cap. This is your displacement vector. Okay, this is your displacement vector. So what is work done? It is dot product of force and the displacement, which I am representing by delta r bar. Okay, so it's equal to 4 I cap plus 3 j cap. So there is no z component in this. It's dot product with 2 I cap minus j cap plus 3k cap. Okay, so this is equal to x component with x component. So 4 times 2. Okay, 4 times 2 plus y component with y component, multiply y component with y component, 3 times minus 1, and z component with z component. So z component is 0, 0 multiplied by anything is 0, so 0 multiplied by 3. Okay, so you have 4 times 2 is 8, 3 times minus 1 is minus 3, 8 minus 3, 5. So 5 joules is the answer. Simple. So let's see this next question. It is similar. A uniform force, this is uniform force, 3I plus j cap Newton acts on a particle of mass 2 kg. As the particle is displaced from this point to this point. Position 2I plus k cap meter to position this position. Okay, the work done by the force on the particle is very simple, right? So force is given, it is 3I plus j, and how much is displacement? So delta r bar is this final position vector 4 I cap plus 3 j cap minus k cap minus the initial position vector, which is 2 I cap plus k cap. So that's 4i minus 2i. So 2i, okay, 3j, so plus 3j, there is no y component here, and minus k cap minus k cap minus 2k cap minus 2k cap. So work done in this process is F bar dot delta r bar, or you can call it S bar. Okay, so it is 3i plus j, its dot product with 2i plus 3j minus 2k. Okay, no need to multiply the z component because there is no z component in force. Okay, so it is 3 times 2 plus 1 times 3, right? 3 times 2 is 6, 6 plus 1 times 3 is 3, so 9 joule is the answer if my calculations are correct. All right, next question. A body moves a distance of 10 meter along a straight line under the action of 5 Newton force. Okay, if work done is 25 joule, then the angle between force and direction of motion of body is. Okay, so this is simple. Work done is dot product of force and displacement. So it is F into S multiplied by cos of theta. And work done is given, it is 25 joules. Force is force is 5 Newton. Displacement is 10. Okay, so it is 5 multiplied by 10 multiplied by cos of theta. So 5 times 10 is 50. Okay, take that 50 on left side. So 25 upon 50 is 1 by 2. Cos theta equals to 1 by 2. So what is the angle? 60 degrees. Right. So this is also a simple problem. Okay. Next problem. A body constrained to move in y direction is subjected to this force. The work done by this force in moving the body through a distance of 10 j cap along y direction, y axis. Right, 150 joules. Just y component with y component. Okay, so 150 joules is the answer. Very good. Next question. When a body moves with constant speed along a circle, options are no work is done on it, no acceleration is produced in it, its velocity remains constant, no force acts on it. So which of this is correct? No, no. See, displacement is okay. See, the reason is force is in this direction. Okay, let's suppose body is at this point. Okay, so what is its velocity? In what direction is the velocity? It's in tangential direction. Okay, so let's suppose it is moving in anti-clockwise sense. This is the force, centripetal force. This is the direction of movement. Okay, this is the velocity. So at each and every point, you can see the angle between force and displacement is how much? 90 degrees. Okay, if you consider any small displacement, okay, consider any small displacement or consider any displacement, at each and every point, the force and displacement, they are at an angle of 90 degrees. Okay, so work done is equal to what? F into, consider any small displacement S multiplied by cos of 90. Cos 90 is 0. So work done is equal to 0. Okay, so therefore no work is done on that object. Is it clear? How to check if two vectors are perpendicular to each other? If two vectors are orthogonal to each other. How will you check? So if two vectors are perpendicular to each other, okay, let's suppose A bar and B bar are perpendicular to each other, then their dot product is equal to 0. Okay, so A bar dot B bar is 0 if A bar is perpendicular to B bar. Okay, so there have been lot of questions based upon this simple topic. Okay, so this one was one of them, right? Because force and displacement are perpendicular to each other, so work done is equal to 0, right? So let's see some more questions. If A bar and B bar, okay, if vectors A bar equals to this thing and B bar equals to this thing are functions of time, then the value of time at which they are orthogonal to each other is. This is the question. So what do we have to do? When two vectors are perpendicular, orthogonal to each other, the dot product is equal to 0. So A bar dot B bar is cos of omega t multiplied by I cap plus sine of omega t multiplied with j cap. Its dot product with cos of omega t by 2 into I cap plus sine of omega t by 2 times j cap. Take the dot product. So x component with x component, y component with y component. So this is equal to cos of omega t multiplied by cos of omega t by 2 plus sine of omega t multiplied by sine of omega t by 2. So tell me, where does this expansion come from? What is the formula? Cos of a minus b. Okay, it is cos a cos b plus sin a sin b. Very good. So this is cos of omega t minus omega t by 2. That is cos of omega t by 2. This is cos of omega t by 2 and this is equal to 0. Okay, we want the time when they become perpendicular to each other. So cos of omega t by 2 is equal to 0. That means omega t by 2 is 90 degrees, right? Or you can say all options are given in terms of pi. So you can say omega t upon 2 is pi by 2. So 2 gets cancelled. So option A is the answer, right? Okay, t equals to pi by omega. So this was simple. If a vector 2i cap plus 3j cap plus 8k cap is perpendicular to vector 4j cap minus 4i cap plus alpha k cap, then the value of alpha is, again simple question. Okay, so a bar dot b bar is equal to 2i cap plus 3j cap plus 8k cap, its dot product with 4j cap minus 4i cap. So it is minus 4i cap minus 4i cap plus 4j cap plus alpha k cap. So it is 2 times minus 4, that's minus 8, plus 3 times 4 is 12, plus 8 times alpha, and if they are perpendicular, this is equal to 0. So 12 minus 8 is 4. Okay, so take that 4 on other side. So 8 alpha equals to minus 4, and therefore alpha is equal to minus 1 by 2. Okay, very simple. Option B is the answer, right? Okay, next question. If vector sum of two forces is perpendicular to their vector difference, in that case the forces, if they are equal to each other in magnitude, are not equal to each other in magnitude, cannot be predicted. This is the question. Okay, so let's try to solve this. So vector sum, so let's call first one f1 bar and second one f2 bar. So vector sum f1 bar plus f2 bar is perpendicular to vector difference f1 bar minus f2 bar. So if they are perpendicular, this is equal to, their dot product is equal to what? 0. Okay, so now let's multiply. So it is f1 bar dot f1 bar. So this is f1 square minus, you have f1 bar dot f2 bar plus f2 bar dot f1 bar and minus f2 bar dot f2 bar. This is equal to 0. Okay, so now see, a bar dot b bar is equal to b bar dot a bar. How? Because a bar dot b bar is what? It is a times b, magnitude of a multiplied by magnitude of b multiplied by cos of the angle between them. And what will be b dot a? B bar dot a bar is magnitude of b. Okay, b a multiplied by magnitude of a multiplied by cos of the angle between them. Okay, so this is magnitude. That means it's a number. So a times b is equal to what? B times a. There is no difference. Okay, so a bar dot b bar is equal to b bar dot a bar, and therefore this thing gets cancelled out. So this is minus of f1 bar dot f2 bar plus f2 bar dot f1 bar. Okay, so f1 bar dot f2 bar is equal to f2 bar dot f1 bar, but here you have negative sign, so this thing gets cancelled out. Okay, f1 bar is equal to, you can say, f1x into I cap plus f1y into j cap plus f1z into k cap. So f1x into I cap plus f1y times j cap plus f1z times k cap. So this thing and its dot product with this thing, what will be that? It will be f1x square plus f1y square plus f1z square. Okay, minus here you have f2x square plus f2y square plus f2z square, and this is equal to 0. So what is this thing? It is magnitude of f1 bar square, right? What will be magnitude of f1 bar? It is square root of f1x square plus f1y square plus f1z square. So this is magnitude of f1 bar square and this is magnitude of f2 bar square. So if square of the magnitudes, so this is magnitude of f1 bar square minus magnitude of f2 bar square, and this is equal to 0. So if this is equal to 0, that means their magnitudes are equal, right? Okay, so which is the answer? Yeah, are equal to each other in magnitude. Very good. So option B is the answer. So is there a question in this? Okay, the position vector of particle is given by r bar equals to a cos omega t into I cap plus a sin omega t into j cap. So this is position vector in uniform circular motion. And in uniform circular motion, the velocity of particle is perpendicular to the position vector, right? Position vector directed along the radius and away from the center. Velocity is directed in tangential direction, right? So we had seen this question in uniform circular motion. Now we can solve this question in another way. So how can we solve this? So this is not actually, this will be a difficult or lengthy way to solve it, but we are just going to solve it. So how do you find velocity? It's derivative of the position vector dr bar by dt. So take derivative sorry. So take derivative of this. What will be derivative of this? So it is a times omega. Okay, why I'm taking omega out? Because it is omega t. Okay, I'm taking derivative of cos of omega t. It will be omega multiplied by minus sine omega t by the chain rule. So multiplied by I cap plus a times omega multiplied by cos of omega t into j cap. So is this thing clear? This is by chain rule. Okay, and now we want to find out whether r bar and v bar are perpendicular to each other. So we'll take their dot product, r bar dot v bar. So what is their dot product? So a omega multiplied by this thing, its dot product with this. So it is a square omega, okay, multiplied by minus sine omega t into cos omega t, minus sine omega t multiplied by cos of omega t, plus we have a times a square omega multiplied by what? Cos omega t into sine omega t into cos of omega t. And you can see here this is same term, okay, but here you have negative sign, so this thing and this thing gets cancelled and therefore the result is 0. And that's why, since r bar dot v bar is 0, they are perpendicular to each other. Okay, so the angle between two vectors, these two vectors will be, okay, so this is simple. So is it 90? Let's check. So theta is equal to cos inverse of, okay, a bar dot b bar, so which is 3 times 3 plus 4 times 4 plus 5 times minus 5. 5 times minus 5. Okay, so it will not be 90, I guess, or will it be? So 4 times 4 is 16. Okay, 16 plus 9. Yeah. Okay, this is equal to 0, and cos inverse of 0 is equal to 90 degrees. Right. So actually the question is based upon this thing. So since a bar dot b bar is equal to 0, okay, it is 3 times 3 plus 4 times 4 plus 5 times minus 5, and this is 0, so angle is 90 degree. Right. Okay, so we'll see one more question. Okay, so let's suppose we have vectors a bar is equal to, let's suppose it is 3i plus 6j uh, minus, actually I will have to pick the vectors whose cos of angle we know. Okay, so yeah, we can do that. We can do that. So let's suppose a bar is equal to 3i cap. Okay, and b bar is equal to root 3. Let's suppose it is 5 by root 2 I cap plus 5 by root 2 j cap. Right. So a bar is this and b bar is this. Okay, and I want to find out angle between a bar and b bar. So this is simple. Okay, so what will be the angle? So we can write cos of theta is equal to a bar dot b bar divided by a by b. Okay, so this is ax bx plus a by by, because we have two components only. So it is 3 multiplied by 5 upon root 2. Okay, and how much is a by by? It is 0, divided by, in denominator, how much is magnitude of a? It is 3, right? Magnitude of a is, it is ax square plus ay square. If there is az also, az square, right? So you have only 3 I cap. So magnitude is square root of ax square only. Okay, or you can say ax square plus ay square. Ay is 0, so this is equal to 3. And how much is magnitude of b? It will be 5, right? So it is square root of 5 by root 2 square plus 5 by root 2 square. 5 square you can take out. Okay, root 2 square is 2. So 5 multiplied by 1 by 2 plus 1 by 2. That's 1. Okay, so magnitude is 5. So it is 3 multiplied by 5 in denominator. Okay, so 3 times 5 gets cancelled out. So 3 times 5 and 3 times 5 gets cancelled out. So you have 1 upon root 2. So now tell me, how much is the angle? 45 degrees. Because cos of theta is 1 upon root 2. Angle between a bar and b bar is 45 degrees. Okay, so have you got it? How to find out angle between vectors? Okay, so this is simple, right? Another use of the dot product or the scalar product of vectors is finding out component of one vector in direction of the other vector. Okay, so let's see how that thing is done. So let's suppose this is a bar. This is first vector a bar, and this is another vector. Okay, this is b bar, or I will draw it with same color. This is b bar. Okay, and now I want to find out the component of A bar along B bar. So how to find component of a vector along other vector, or in any direction we can say. So I can resolve this A bar in two components, right? One along B bar, one perpendicular to B bar. Okay, so the component along B bar would be this much, component perpendicular to B bar would be this much. So if this angle is theta, okay, if I know this angle, then how much would be this component? So we can say B bar is in x direction, so this component is ax, so this is equal to a cos theta, right? And this component will be a sin theta. Okay, so what is component of A bar in direction of B bar? It is a cos theta. Yes, no? And what is theta? Theta is the angle between A bar and B bar, right? So if I know A bar, if I know B bar, okay, I know what is cos of theta. What is cos of theta? It is A bar dot B bar divided by magnitude of A bar multiplied by magnitude of B bar. Okay, and I want component of A bar along B bar, right? So this is cos of theta, and I want component of A bar along B bar. So component of A bar along B bar in direction of B bar is what? Is equal to A times cos theta. So now I know an expression for cos of theta. We have studied it. And I know the component of A bar along B bar is A cos theta. So what will be that? It is A times this, okay, this relation for cos of theta. So which is A bar dot B bar divided by AB. So this A, magnitude of A and magnitude of A gets cancelled out. What relation do you get? It is A bar dot B bar divided by B. Okay. And similarly, what will be component of B bar along A bar? Right. A bar dot B bar divided by magnitude of A. Okay. So this is simple, and let us see problems based upon this topic. So given A bar equals to this thing, B bar equals to this thing, the component of vector A bar along vector B bar is, so this is simple. Okay, it is, oh, you calculated, good. So it is A times cos theta, and it is A bar dot B bar divided by magnitude of B. Okay, let's find it out. 2I cap plus 3j cap, its dot product with I cap plus j cap, and divided by magnitude of B, which is square root of bx square plus by square. So bx is 1 square plus 1 square, root 2, right? So 2 times 1, 2, 3 times 1, 3, right? So it is 5 upon root 2. Very good. All right. So option C is the answer. So simple to find out components, right? Okay. So let's try one more problem. So here. So component of projection of A bar on B bar. So this is another name for finding out component. Projection of A bar along B bar. Okay. So projection means what? Component only. Okay. Or you can say this is projection of A bar on B bar. Okay. So if you keep a mirror over here, if you keep a mirror over here, how much will be length of A bar in that mirror? It is known as the projection of A bar. Okay, on that mirror, or you can say in this direction. So projection of A bar along B bar is what you can say that if you, let's suppose, um, you shine some light over here from here. Okay, so this is a stick. Okay, A bar is a stick, and you shine light like this. So what will happen? So suppose this is the floor. So there will be some shadow of this A bar, this stick. And how much would be length of that shadow? It would be this much, right? So it is projection of A bar on B bar. You got this? These are different names. The component, the projection, or there can be a question like this. If okay, so if you shine light like this, what will be the length of shadow of this vector? Or a stick is kept there. Okay, a stick is kept here. How much would be the length of the shadow of that stick? How much would be the length of shadow? It's equal to the component of this vector. Okay, in this direction. That much would be the length of the shadow of the stick. Got it? Yes, no? So let's move on to, let's see this problem. This is simple. So what will be the projection of A bar on B bar? So projection of A bar on B bar, it is just another name for the component. So it is A cos theta, which is A bar dot B bar divided by B. So tell me, 2I cap plus 3J cap, sorry, I wrote 3I cap. 2I cap plus 3J cap minus K cap, its dot product with minus I bar I cap plus 3J cap plus 4K cap divided by, good. So it is 1 plus 3 square is 9 plus 4 square is 16. Okay, so option B. Let's check 2 times minus 1. Okay, 2 times minus 1 is minus 2 plus 3 times 3 is 9 minus 1 times 4 is minus 4. And in denominator you have 26. So 9 minus 4 minus 2. Right, option B. So 3 upon root 26. Very good. Okay, so option B is the answer. Right, so this is how we find out the component of a vector, one vector along another vector or in any direction. Force F on a particle moving in a straight line varies with distance d as shown in this figure. The work done on the particle during its displacement of 12 meters is. So this is from NEET 2011. Very simple question. Tell me the answer. So we know work done is equal to what? Area under force versus position curve, or force versus, yes, 13 joules. Right, it is area of this rectangle and area of this triangle. So area of this rectangle, okay, it is half of base multiplied, sorry, area of the triangle is half of base multiplied by height. Area of the rectangle is base multiplied by height. Okay, so 7 minus 3, 4, 4 times 2. So this is 8, and this is how much? 12 minus 7 is 5. 5 multiplied by 2 divided by 2. Yeah, so it is 5. So 8 plus 5, 13 joules. Okay, this was very simple. This is simple, right? So this question is, a force acting on an object varies with distance x as shown. The force in Newton and x is in meter. Was it given in last question? Yes. So units were given along x and y axis. The work done by the force in moving the object from x equal to 0 to x equal to 6 meters is x equal to 0 to x equal to 6. So this is similar question, right? So 3 times 3, 9 plus how much? 3 times 3, half of that, 4.5. So 9 plus 4.5, 13.5. Okay, so option B is the answer. All right. Then next question. This is from NEET 2019. A force 20 plus 10y acts on a particle in y direction where F is in Newton and y in meter. The work done by this force to move the particle from y equals to 0 to y equals to 1 meter is. Okay, so now what do we have to do? This is one-dimensional problem. So F is function of y only and displacement is also in y direction. Okay, so the work done is equal to integral of F dot dy, right? From y equals to 0 to y equals to 1. So from 0 to 1. And it is equal to integral of 20 plus 10y dy from 0 to 1. Okay, so that's value of force only, 20 plus 10y. And you can separate this into two integrals. So it is 20 dy, integral of this from 0 to 1, plus integral of 10y dy from 0 to 1. Okay, and that is equal to integral of 20 dy. So 20 you can take out. Integral of dy is y. Okay, so 20 times y from 0 to 1 plus 10 you can take out from the second integral, and integral of y dy is y square upon 2. So y square divided by 2. Y square upon 2 from 0 to 1. So how much is this? Substitute the upper and lower limits. So 20 times y. Okay, y only. So when y is equal to 1 minus y equals to 0. Plus, you can divide by this 2. So it is 10 by 2, 5. So 5 multiplied by y square is 1 minus what? 0. 1 square minus 0 square. Okay, or 1 minus 0 again. So how much is the answer? 20 plus 5. 25 joules is the answer. So repeated in 1992, 1994. Okay, same question with same values. A position dependent force. You solved it so fast. Oh, very good. So a position dependent force, F equals to this thing, acts on a body of mass 2 kg and displaces from 0, x equal to 0 to 5 newtons. The work done in joule is. Okay, so let me solve. It is integral of f dot dx from 0 to 5. Okay, so it is, how much is f? F is 7 minus 2x plus 3x square. Okay, from 0 to 5 dx, and it's equal to 7 you can take out, integral of dx from 0 to 5, minus 2 you can take out x dx from 0 to 5, plus 3 you can take out, it is x square dx from 0 to 5. All right, so it is equal to, work done is equal to, integral of dx is x, 5 minus 0. So 7 multiplied by 5 minus 0 minus 2 multiplied by, it is x square upon 2. Okay, from 0 to 5, and plus it is 3 times x cube divided by 3. Okay, integral of x square dx is x cube upon 3 from 0 to 5. All right, so this is equal to, w is equal to 35 minus this 2 and 2 gets cancelled. So 5 square is 25 minus 25, and plus 3 gets cancelled. 5 cube is 125. 135, right? A particle of mass m1 is moving with velocity v1. Okay, it's moving with velocity v1, and another particle of mass m2 is moving with velocity v2. Both of them have same momentum, but their different kinetic energies are E1 and E2 respectively. If m1 is greater than m2, then E1 is less than E2, or E2 by E1 upon E2 is M1 upon M2. E1 is greater than E2, or E1 equals to E2. This is from 2004. So which is the answer? This is very straightforward. Okay, see, the bodies have same momentum. That means we have to consider which formula for kinetic energy? The formula in terms of momentum, right? So kinetic energy, let's denote it by E. It is P square upon 2m. Okay, momentum is same, so energy is inversely proportional to mass, right? Energy is inversely proportional to mass. Kinetic energy is inversely proportional to mass. So if mass is more, energy will be less. If mass is less, energy will be more. What's the answer? M1 is greater than M2. So E1 would be less than E2, right? This is the answer. Okay. So this is actually, what can we say? So this thing should come into the mind very instantaneously. Okay, E equals to P square upon 2m. Just like when we say kinetic energy, two formulas should come to our mind now. Okay, one is half of mv square, second is P square upon 2m. Okay, so whether the velocity is given or the momentum is given, depending upon that. So momentum is given, momentum is same. Kinetic energy is inversely proportional to mass now, because momentum is equal. Okay, so we have to use this formula. So if mass is more, energy will be less. If mass is less, energy will be more. So since m1 is greater than m2, E1 will be less than E2. Next question. These are all NEET questions. Okay, very, very simple. Okay, so if kinetic energy of a body is increased by 300%, then the percentage change in momentum will be. So again, this is simple, right? Kinetic energy is increased by 300%. Okay, so we can say K2 upon K1 equals to how much? What will be the ratio? If it increases by 300%, that means K2 is 400%. Okay, so K2 will be 400% of K1. Okay, increment is 300%. Okay, so K2 equals to K1 plus how much? 300% of K1. Okay, I'm sorry. So K2 equals to what? K1 plus 300% of K1. So 300% means what? 3 times K1. If K1 is 100%, 300% is 3 times K1. So K2 is equal to what? How much? It is 4 times K1. Okay. And you know that it is equal to what? P2 square upon 2 times M upon P1 square upon 2 times M. Right? Yes, no? Okay. So mass and mass will get cancelled, and you have, or you can directly say it is directly proportional to momentum square. Okay, because mass will not change. So P2 upon P1 square is equal to 4 upon 1. And therefore, how much will be P2 upon P1? Take square root. It is 2 upon 1. So if P1 is 100%, how much would be P2? So P2 is 200% of P1. Sorry. So P2 is 200% of P1, or P2 equals to 2 times P1. So how much is the increment? Increment is 100%, right? Okay, good. So it's again extremely simple problem. Okay, and you don't have to do all this, right? You can do it in your mind. Kinetic energy increases by 300%. Okay, that means final kinetic energy is 400% of initial kinetic energy, or you can say it is 4 times initial kinetic energy. Okay, and directly you can say that kinetic energy is directly proportional to momentum square. So you can directly write down, okay, K2 by K1 is equal to what? P2 by P1 square. Okay, and then you can put K2 upon K1 equals to 4 is to 1. So P2 by P1 is equal to what? 2 is to 1. The problem solved. Let's move on to the next problem. So two bodies with kinetic energies in the ratio 4 is to 1 are moving with equal linear momentum. The ratio of their masses is, see how many questions have been asked based upon this. Okay, so two bodies with kinetic energies in ratio 4 is to 1 are moving with equal linear momentum, right? The ratio of their masses is 1 is to 4. Very good, Sanjay. Okay, so momentum is given. That means you will use which formula? You will use p square upon 2m. So this is kinetic energy, or I can write k. Generally I use k only. So k1 equals to p square upon 2m1, k2 equals to p square upon 2m2. Okay, k2 equals to p square upon 2m2, right? So momentum is given to be equal. So that means you can directly use this relation. The kinetic energy is inversely proportional to mass. Okay, so k1 upon k2 equals to m2 upon m1, because they are inversely proportional. Okay, and uh, you are given k1 by k2, which is 4 is to 1. So m2 upon m1 will be 4 is to 1. So m1 upon m2, or m1 is to m2, will be what? 1 is to 4. Okay, very simple. Option D. Right? All right. Let's see next question. Oh, can you see this? Okay. So 1989, 1997, 1998. They repeated it 3 times. And okay. So two bodies of masses. Okay. So did you have this perception that questions are not repeated in the NEET exam? Yes, no? Okay. So questions are repeated. We are seeing that questions are repeated lot of times. Okay. So questions will be either same. Okay. They are not, most of the times, not repeated word to word. So what is done? They will change the values. Okay. Either they will change the value or they will tweak it a little bit. Right. All right. So this is very simple question. Two bodies of masses m1 and 4m, m and 4m are moving with equal kinetic energies. The ratio of their linear momenta is. So again, we'll use kinetic energy k1 is to k2 equals to what? p1 square upon 2m1, and we'll use this a lot, that dividing by something is equal to what? Multiplying by its reciprocal. So 2 times m2 upon p2 square. Okay, so this will simplify the process. Okay, so this is very simple. K1 upon K2, the two bodies are moving with equal kinetic energy. So this is one. That means you are given what? With masses. M1 is to M2 is how much? 1 is to 4. Okay, so you have P1 square upon P2 square, or P1 by P2 square. So M2 is 4 times M1. 4m divided by m. So m and m get cancelled. You can take that 4 on the other side. It goes into the denominator. So P1 by P2 square is 1 by 4. So what's the ratio of P1 is to P2? 1 by 2. So let's see this next question. This is repeated 1997, 2001. A particle is projected making an angle 45 degrees with the horizontal having kinetic energy K. The kinetic energy at the highest point will be. Tell me. We have solved these kind of questions. Okay, similar questions in projectile motion. It will be K by 2. Or did you forget? So it is projected making an angle 45 degrees. Okay, making an angle 45 degrees with the horizontal. So how much would be its x component and y component of velocity? U cos theta, u sin theta, right? So for 45 degrees, cos theta and sin theta is equal, right? It is 1 upon root 2, 1 upon root 2. Okay, so this will be u sin theta, that is u upon root 2, because sine of 45 is 1 upon root 2, and this will be u cos theta, which is 1 upon root 2. So x component of velocity is u upon root 2, y component of velocity is also u upon root 2. Okay, and what happens at the topmost position? The body will have only x component of velocity, right? So kinetic energy here will be equal to half of m into ux square only. So let's call it k at h, and this is original k. Okay, so it is half of m into ux square, and how much is ux? U upon root 2 square, so that is u square upon 2, or you can say it is equal to what? Take that 2 out, so it will be 2 times half of mu square. Okay, so it is 2 times, or not 2 times, half times half of mu square. Okay, so that is half of initial kinetic energy, right? So let's see this next question. A ball of mass 2 kg and another of mass 4 kg are dropped together from a 60 feet tall building. Okay, so they are dropped together from a 60 feet tall building. After a fall of 30 feet, each towards earth, their respective kinetic energies will be in the ratio of. Tell me. This is simple, right? See, there are two masses. They are dropped from some height, same height. Okay, so does this acceleration, does their acceleration depend on their masses? No, right? It doesn't depend on mass. Okay, both of them will fall with same acceleration, which is acceleration due to gravity. Okay, so therefore, so now after a fall of 30 feet each towards earth, so they are falling to 30 feet each towards earth, their velocities will be equal. Yes, no? And if velocities are equal, then kinetic energy, so it depends on mass only now. Okay, I mean the relative kinetic energy depends on the mass only. So their masses are 2 kg and 4 kg. So after a fall of 30 feet each, okay, their velocities will be equal. Velocities at this point will be equal because both of them will fall with same acceleration, which is acceleration due to gravity. So since velocities are equal, kinetic energies are in the ratio of what? Ratio of masses only. So mass is 2 kg and 4 kg. So kinetic energies K1 is to K2 is equal to M1 is to M2 only. Okay, so that is 1 is to 2. This is the answer. Yes, no? Alright, so let's try to solve these problems based upon the conservative forces and potential energy. So, see this problem. The potential energy of a system increases if work is done. And options are upon the system by a non-conservative force, by the system against a conservative force, by the system against a non-conservative force, upon the system by a conservative force. What's the answer? Can you guess? The potential energy increases if work is done against the conservative force or by the conservative force.
Against the conservative force.
Against the conservative force. Very good. So, where is against the conservative force? Option B. Option B is the answer. Right? It's simple. Very simple question. So, this is from NEET 2011. Okay. Next question. If W1, W2, and W3 are work done in moving a particle from A to B. Okay, so you are moving a particle from A to B along three different paths, 1, 2, and 3, respectively, as shown in the gravitational field of a point mass m. The relation between W1, W2, and W3 is, what is the relation? So this is exactly what we saw yesterday. This is exactly what we proved yesterday. Work done against the gravitational force or work done by the gravitational force. Does it depend on the path or it does not depend on the path? Sorry. Does it depend on
Independent of
path?
the path.
It is independent of the path. So what's the answer? Option B is the answer.
Yes,
Right?
sir.
Okay, clear everybody? Yes, Ravindran? Okay, good. Next question. The slope of potential, I'm sorry. Okay. So the slope of potential energy versus position graph gives the magnitude of. So what is slope of potential energy versus position? It is derivative of potential energy versus position. It gives the magnitude of what? So we know that conservative force is given by minus of du by dx, right? So if you have,
Rate of change of momentum.
very good. Okay. So it gives you force. That means it gives you what? The rate of change of momentum. Because according to Newton's second law, what is force? It is equal to rate of change of momentum with respect to time. Okay. So the answer is option C. Yes, everybody?
Yes, sir.
Okay, Ravindran. Okay, good. Sorry. Next question. So this is from NEET 2012. The potential energy of a particle in a force field is U equals to A divided by R square minus B divided by R, where A and B are positive constants and R is distance of particle from the center of the field. Okay. For stable equilibrium, the distance of particle is. So what happens at this stable equilibrium? Du by dr will be equal to 0, right? So this can be written as d by dr, or I will write this as A multiplied by R raised to minus 2, okay, minus B multiplied by R raised to minus 1. So this is equal to 0. Fine. What I have done is I have taken this R raised to 2 in numerator, so it becomes R raised to minus 2. So R raised to 1, R means R raised to 1. In numerator, it will become R raised to minus 1. Now let's take derivatives. So if you take derivatives, what will you get? So derivative of this using the formula, derivative of R raised to n. It is n R raised to n minus 1. So this is R raised to minus 2. That means you will have minus 2 multiplied by R raised to minus 3. Okay, this is derivative of this term. A is constant. Okay, minus B multiplied by minus 1 multiplied by R raised to minus 1, that's minus 2. Okay, so here n is minus 1. Okay, and you have, when you take derivative, it becomes n minus 1. So minus 1, it is minus 2. Here n is minus 2, minus 2 minus 1 is minus 3, right? So this can be written as what? So you can write this as minus 2a divided by r cube, okay, and this minus minus becomes plus, plus b divided by r raised to 2. This is equal to 0. You can take r raised to 2 common, okay, divide both of these terms by r raised to 2 and take that 2a on the other side, 2a upon r. So here if you divide by r raised to 2, you will have r here, right? So it is 2a upon r equals to b, or r equals to what? 2a divided by b. Okay, so you have this point at which the derivative of potential with respect to the derivative of potential energy with respect to r is 0. That means you will have equilibrium at this point. Okay, that means force will be equal to 0. So which is the answer? Option B is the answer. So let us see next question. Next question is similar, but it is way back from 1995. The potential energy between two atoms in a molecule is given by U of x equals to this thing, okay, where A and B are positive constants and x is distance between the atoms. The atom is in stable equilibrium when? Okay, so let's take derivative again. So for stable equilibrium, du by dx is equal to 0. And now it is d by du of what? This thing, a divided by x raised to 12 minus b divided by x raised to 6. Okay, so shall I take the derivatives directly now? Okay, so if you take the derivative, it will become minus 12. Okay, if you take this in numerator, it is x raised to minus 12. If you take its derivative, it is minus 12 multiplied by x raised to minus 13. That is minus 12 divided by x raised to 13. Right? That's what I am writing. So minus 12 a divided by x raised to 13. And here it will be minus 6. Okay, minus 6b divided by x raised to 7. Right? And this is equal to 0. So then this becomes minus minus becomes plus, I'm sorry. So you have what, divide these two terms by x raised to 7. So you have minus 12a upon x raised to 7. Okay. Sorry. So what I can do is I can divide these two terms by x raised to 7. What will be this thing then? It will be x raised to 6, right? And then you can divide these two by 6 also. Okay. So this becomes minus 2a upon x raised to 6. Okay. Plus b upon 1 equals to 0, right? Or you can say this is equal to 2a upon x raised to 6 is equal to b, or x raised to 6 is equal to 2a divided by b. Okay, and this gives you x is equal to 2a upon b raised to 1 by 6. Okay, right? You take sixth root on these both sides because you have x raised to 6. So this is the answer, 2a upon b raised to 1 by 6. Option A is the answer. So clear? Yes, no?
Clear, sir.
Yes, sir.
Good. Okay, so all these questions are simple, right? Next question. A particle with total energy E is moving in a potential energy region U of x. Motion of the particle is restricted to the region when? Okay, U of x is less than E, U of x is less than or equal to E, U of x is equal to 0, U of x is greater than E. So can you tell me what's the answer? We know law of conservation of energy, yes, no? Sum of potential energy plus kinetic energy is total energy.
Yes, sir.
Okay, so we can say U of x plus some kinetic energy, half mv square, is equal to the total energy, right? And this half of mv square kinetic energy will have some positive value, right? It will have some positive value. So if this is positive, okay, if this is positive, so you have to add something to U of x to get energy E, right? At least how much can be the kinetic energy? The minimum value of the kinetic energy will be equal to 0. Okay, so since you have to add something to the potential energy to get the total energy, that means potential energy is less than total energy, right? At the most it can be equal to the total energy. When it will be equal? When v is equal to 0. V meaning the velocity is equal to 0, right? So u of x is less than or equal to the total energy. Option C is the answer. Okay, potential energy of a particle, they are saying it's proportional to, it's not alpha. Okay, I'm sorry. So potential energy of a particle is proportional to, coordinate by equation x square minus 2x. So u of x is proportional to x square minus 2x. Okay, that's what they are saying. Will be equilibrium at. So this is simple.
Option
So
C.
since, yeah, maybe option C. Let's check. Okay, so for equilibrium, du by dx is equal to 0. That means d by du, sorry, d by dx of x square minus 2x is equal to 0. So derivative of this thing is 2x and derivative of this term is minus 2 only. Okay, because derivative of x is equal to 1. So 2x minus 2 is equal to 0, right? So x is equal to 1. Option C is the answer. Very good, Sanjay. A particle which is constrained to move along x-axis. Particle is constrained to move along x-axis, subjected to a force in the same direction which varies with distance x of the particle from origin as this. Okay, this is the function f of x equals to minus kx plus ax cube. Okay, here k and a are positive constants. For x greater than 0, the functional form of potential energy u of x of the particle is. This is the question. Okay, what is the functional form of the potential energy u of x? So what do we need to do? Let's integrate this, right? So we know the relation between potential energy and the force, conservative force. What's the relation? Integral of minus of f of x, okay, dx from 0 to x. Why 0 to x? Because we want the value of potential energy beyond 0, okay, after 0, I mean, right? 0 and so for values of x which are greater than 0. So this is equal to potential energy at x minus potential energy at 0. Okay, so then let's substitute the values. Let's substitute f of x. So what do we get? It's integral from 0 to x of minus kx. We have this negative sign also, plus ax cube dx. Okay, and this is equal to this term. So we have two integrals here. So this minus minus becomes plus. K we can take out. So integral of x dx from 0 to x, and minus a I can take out. So integral from 0 to x of x cube dx, which is equal to, so this will become x square upon 2, right? Because lower limit is 0 only. Okay, so k times x square upon 2 minus, this will become what? X raised to 4 divided by 4. Okay, so minus a multiplied by x raised to 4 upon 4. So this is your potential energy function, right? This is the potential energy function. Okay, so put x equal to 0. What will you get? Okay, see, actually what we can find out it is, we can just find out this thing. Okay, we can just find out the difference in potential energy. We cannot find out potential energy. Okay, so we have to take some constant. We don't know what is potential energy at x equal to 0, but from this form what we can guess is what will happen when x will go on increasing. Okay, what will happen when x will go on increasing? So as x increases, what will happen? X raised to 2 will increase, but x raised to 4 will increase even more fast, right? Very, very fast compared to x raised to 2. Okay, so let's suppose, I'm sorry, let's suppose x is equal to 10. So x raised to 2 will be what? Will be 100. But x raised to 4 is what? It will be 10,000, right? Okay, and this is negative. This is negative. That means what will happen? The potential energy, the change in potential energy, okay, will go on decreasing. Decreasing meaning what? It is negative as x goes on increasing. Okay, so for higher and higher values of x, if you take the potential energy at that x, okay, so this is u, this is x. So for higher and higher value of x, if you take potential energy at that value of x, that is u of x, minus potential energy at 0. The potential energy at 0 will have some value. Okay, so for understanding, let's suppose it is 0. Okay, let's suppose, okay, so I'm not saying it will be 0. Let's suppose it's 0. You take some value. So if this value is above the x-axis, what will happen? The difference will be negative or positive. The difference will be positive. right? But if this value is below the x-axis, then difference will be positive or negative? The difference will be negative. And as we can see here, u of x minus u of 0. What's happening to this thing, u of x minus u of 0, as x increases? So this becomes more and more negative. Okay, so that means this graph will go down like this. So this is the answer. A conservative, it would be a force, right? A conservative force is given by F equals to K by R. When K is a positive constant, if the potential energy is 0 at R equals to R naught, find the expression for potential energy as a function of R. Okay, so this is given just like the last problem. What we will do is we'll take integral of f of c dr from R naught to some R, and this will give us what? It will give us potential energy at R minus potential energy at R naught, right? So minus of integral of conservative force from some initial to final value. It gives us potential energy at final value minus potential energy at the initial value. Okay, this we know. And they have given that the potential energy at R naught, it is 0. Okay, R equals to R naught is 0. So the second term is 0, right? So we get UR only on the right hand side. So this is what is that conservative force? It's K by R. So minus of integral from R naught to R of K by R. K you can take out because it's a constant. 1 upon R dr. And what is integral of 1 upon R? It is log R, right? It is log R. Everybody knows this?
Yes, sir.
Okay. So integral of this is log of R. Lower limit is R naught, upper limit is R. And you have minus of K. So U of R. Then substitute the upper and lower limit. So it is log of R minus log of R naught. Okay. So minus of K multiplied by log of R minus log of R naught. This is equal to U of R. Or you can say, if you multiply with this negative sign, it is log of R naught minus log of R. If you take negative sign inside. Okay. So log of R naught minus log of R. So log A minus log B equals to log of A by B, right? Because all options are given like this. Okay, so it will be K times log of, so they have given minus K times. Okay, so let's keep negative sign outside only, right? So U of R is equal to minus K times log of R upon R naught. This is the answer. Okay, so option B is the answer. This is clear? All right. Next question. A particle in a region of, a particle in a certain conservative force field has a potential energy given by U equals to this thing. The force exerted on it is. So this is again a straightforward question. So we know that F equals to minus of derivative of U with respect to what? So now here we have three coordinates. Okay, so x, y, and z, right? So we have to take three components of force. So remember the full formula. So it is minus of partial derivative of u with respect to x multiplied by I cap plus partial derivative of u with respect to y multiplied by j cap plus partial derivative of u with respect to z multiplied by k cap, right? This is the full formula. Oh, what's happening? Anyways, you can see this, no? Yes. So then let's substitute the value of u. So minus
Option
of,
C.
you got this? Okay, let's check. Very good. So partial derivative of u, which is 20 xy upon z. So 20 we can take out. Okay, 20 we will keep out. Or yeah, so let's keep out. Minus 20. So xy upon z. Okay, plus partial derivative of xy upon z with respect to y, plus partial derivative of xy upon z with respect to z. Okay, and this multiplied by I cap, this multiplied by j cap, this multiplied by k cap. Okay, so what's the rule of taking partial derivative? You will treat other terms as constants. Okay, so, oh, my mistake, I wrote z here. Okay, so when you take partial derivative with respect to x, you will treat y and z as constant. So these are constant. Okay, so it is minus 20 times, these are constants. What is derivative of x with respect to x? It's 1. Okay, so what is derivative of this term then? So y and z you can take outside, y upon z only. Okay, so it is y upon z times I cap, plus when you take partial derivative with respect to y, you will treat x and z as constants. So take them out, x upon z out, multiplied by j cap, because derivative of y with respect to y is 1. And next you have derivative of this thing with respect to z. So x and y are constant, you can take them out. Derivative of 1 upon z is minus 1 upon z square, right? It is minus 1 upon z square. So it is minus xy divided by z square, okay, multiplied by k cap, right? So this is the answer. So which option did you say, Sanjay?
Option C, I say, but option B
Okay,
is correct.
yeah, it is option B, because we have this extra negative sign, no? So it is option B, right? Because this minus and minus will become plus. Okay, so this is the answer, option B. Let us discuss some problems based upon this. A body of mass 3 kg is under a constant force which causes a displacement s in meters in it, given by relation s is equal to 1 by 3 t square, where t is in seconds. So work done by the force in 2 seconds is, okay. So now you are given with the displacement and t is in seconds. The work done in 2 seconds is, so s is equal to 1 by 3 t square, okay. Force is constant force, and we know work done is equal to what? Change in kinetic energy, right? Work done is equal to what? Change in kinetic energy. So I can take derivative of this. So what will be ds by dt? That's velocity, right? And what will be that? It will be 2 times t divided by 3, right? Derivative of this thing, derivative of t square is 2t, and you have this 3 in denominator, okay. So v is equal to this thing, and therefore you can say the work done is equal to final kinetic energy minus initial kinetic energy, or kinetic energy at t equals to 2 seconds minus kinetic energy at t equals to 0. Okay, so this is what will be kinetic energy? Half of m multiplied by v square. What is velocity at t equals to 0? It's 0, right? So u is equal to 2 times 0 divided by 3, that is 0. right? Okay, and at t equals to 2, what will be its velocity? So it is 2 times 2 divided by 3. Okay, that is 4 upon 3. So take 4 upon 3 square, or here I will put 0. Here it is 2 times t divided by 3 square, right? So it is half of m multiplied by 4 times t square divided by 3. And you can cancel out this 4 by 2. So 2 will remain there. And now we can substitute values. So mass is 3, t is 2. Okay. So it is 3 multiplied by t square, which is 2 square. So that's 4. 4 times 2. 4 times 2 is how much? 8. Okay. And this 3 and 3 will get cancelled because mass is equal to 3. Oh no, I have to take square of this thing also, no? Sorry. Okay, it will be 9 here. Okay, 3 square. So mass is 3. Okay, so you will have 8 divided by 3. Okay, 8 divided by 3 will be the answer.
Yes, sir.
Right?
Yes, sir.
Okay, I had done a mistake here. Okay, anyways, so I didn't take square of this thing, 3. All right, so this is clear to everybody. Okay, so this is how we can use the work energy theorem. Okay, let's discuss next problem, which is similar. A force acts on 3-gram particle in such a way that the position of the particle as a function of time is given by this thing, where x is in meters, e is in seconds. Okay, the work done during first 4 seconds is, so find out velocity, right? X is given 3t minus 4t square plus t cube. Find out velocity. So dx by dt is what? So 3 minus derivative of this will be what? 2 times t multiplied by 4. So it is 8t plus derivative of this thing is 3t square. 3t square. Okay. So this is velocity, right? So let's suppose initial velocity is u. How much is u? Put t equals to 0. So this term will be 0. This term will become 0. So u is equal to 3 meters per second. And the velocity at 4 seconds is suppose v. Okay, so v is at t equals to 4. How much is that? So 8 times 4 is 32, and this is what? T square. So 16 times 3 is 48. 48 minus 32. How much?
16.
16. 16 plus 3. How much? 19. Right? 19 meters per second. Okay. And then what will be the work done? Work done is equal to final kinetic energy minus initial kinetic energy. Okay. So let's take m by 2 out. M by 2 v square minus u square. What is m? 3 grams. So 3 multiplied by 10 raised to minus 3 divided by 2. 19 square. What is 19 square? So see, we can use trick like this. Okay, this would be difficult, multiplying 19 with 19. So what you do is multiply 19 with 20 minus 1. Okay, so this thing is, so ultimately what you are doing, you are finding 19 square. So 19 times, okay, because 20 minus 1 is 19. 19 times 19. Okay, so 19 times 20 is 380 minus 19 times 1 is 19. Okay, so that's how you can find out squares. Okay, if you don't know. All right. So 361 minus u square. How much is u? It is 3. 3 square is 9. Okay. So 361 minus 9 is how much? 353. Sorry, 352. Okay. 352. 352 divided by this 2. So it is 352 divided by 2. It will be how much? 176. 176 multiplied by 3. 528. This is answer. 530. Option D is the answer. Right? If my calculations are
Yes,
correct.
sir.
Okay, Ravindran? All right. So 528 multiplied by 10 raised to minus 3 is 528 millijoules. And closest one is 530. So this is the answer. Right. All right. Let's move on to the next problem. The kinetic energy acquired by mass m in traveling distance d starting from rest under the action of a constant force is directly proportional to kinetic energy acquired by a mass m in traveling distance d starting from rest under the action of constant force. Okay, so force is constant. What is the kinetic energy acquired? So they are saying it is starting from rest. Okay, so we know the final kinetic energy minus initial kinetic energy is equal to the work done. This is work energy theorem. Okay, and it is starting from rest. So initial kinetic energy is 0. Final kinetic energy is equal to work done by a constant force. So what will be that constant force? Sorry, what will be the work done by constant force? Force multiplied by displacement. It is force times displacement. Okay, so force is constant. Displacement is given. It's d. So does it depend on mass? Yes, no.
Yes, sir.
Is it depending on mass? Tell me. Kinetic energy of any object, okay, which you are pushing, let's suppose with a constant force in same direction, it is equal to F times D, force times displacement. Okay, so it doesn't depend on mass, it is F times D. It depends on force and the displacement only. What will depend on mass? See, kinetic energy is half of m into v square. So what will happen? If mass is less, speed will be more. If mass is more, speed will be less. But the kinetic energy that you are giving, okay, by pushing that object with constant speed, it will be same. It does not depend on mass. Got it? Yes, no? Option B is the answer.
Yes, sir.
Yes, sir.
Okay, is there a confusion? They are not
Yes, sir.
asking you the, yeah, they are not asking you the formula for kinetic energy. Okay, so kinetic energy is half of mv square. It will depend on mass, right? If you take the formula for kinetic energy. So under this scenario, what's happening? You are pushing that object from rest, starting from rest. So you are applying a constant force F. Okay, let's suppose of 100 Newton, and the displacement is 10 meters. So how much would be the kinetic energy? 100 times 10. So have we considered a mass here? Whatever is the mass, let's suppose the force is 100 newtons, displacement is 10. So how much would be the kinetic energy? if you push that object starting from rest with a force of 100 Newton and you give displacement equal to 10. So it will be 1000 joules. Okay. Doesn't matter how much is the mass. If mass is less, velocity will be more. If mass is more, velocity will be less. Okay, this product of half of mv square will be equal to what? 1000 joules. So it does not depend on the mass. Clear now? If there is any confusion.
Yes, sir.
Clear, sir.
Yes, Ravindran? Okay, good. Then let's see the next question. A particle of mass m at rest is acted upon by a force P for time t. Kinetic energy after an interval t is. So this is the question. Okay. So it is acted upon by a force P. P is the force. Okay. So now, so can you find out momentum? It is starting from rest. Okay. So momentum, and I will take small p for that. It's equal to mass times velocity, and its initial momentum will be 0, right? Okay, initial momentum will be 0. So what will be momentum? Final momentum? See, this P will be equal to, force is equal to final momentum mv minus initial momentum, which is 0, divided by t. So final momentum, okay, mv is equal to what? P times t, right? And therefore now you want, okay, kinetic energy, which is half of m into v square, which is equal to, you can say this half of, I can write this as m square v square divided by m, or p square upon 2m, right? Which p? The small p, which is momentum. And that is mv square can be written as p square t square, right? Pt square, p square t square divided by 2m. So this will be the answer, right? Option B is the answer.
Clear, sir.
Others?
Yes, sir.
Ravindran? Oh, you already said clear. Ravindran, can't you speak? All right. Let's move on to the next problem. The rate of decrease of kinetic energy is 9.6 joules per second. Find the magnitude of force acting on particle when its speed is 3 meters per second. Okay, so what is given? The rate of decrease in kinetic energy is given. Okay, no problem. So the rate of decrease in kinetic energy, this is given. So derivative of kinetic energy with respect to time, this is given. Okay, and find the magnitude of force, this is the question. All right, so can we write F times dx for small displacement? F times dx is equal to change in kinetic energy, because work done is equal to what? Change
Yes,
in,
sir.
right? So work done is equal to change in kinetic energy. So for small displacement, I can write this is equal to dk. Okay, and then you are given with dk by dt. So I can write this as, I'm dividing by dt on both sides. So dk by dt is f times dx by dt. And what is dx by dt? It is v. Okay, and what do you want? You want force only. So take v on other side. So you get force is equal to 1 upon v multiplied by dk by dt. So dk by dt is given, right? V is given. Okay, and you got the force then. Okay, so it is 9.6 divided by v. Dk by dt is 9.6 divided by v is 3. So 3 3s are 9, 3.2. 3.2, yes, option A. So 3.2 newtons is the answer. Is it clear? So what is the minimum velocity with which a body of mass m must enter a vertical loop of radius r so that it can complete the loop? This is very straightforward. Tell me the answer. What is the minimum velocity with which a body enters a vertical loop? So where is the minimum velocity? At which point? This point, this point, this point? At the topmost point, right? How much is that? Square root of gr. We solved it, no? Okay. So answer is square root of gr. Yes or no? Okay, this is a direct question, a straightforward direct question, right? Let's see the next one. A mass m is attached to a thin wire and whirled in a vertical circle. The wire is most likely to break when the option A inclined at an angle of 60 degree from vertical, the mass is at the highest point, the wire is horizontal, the mass is at the lowest point. Tell me, where is the tension maximum? When mass is at the lowest point. So where will this string break? When mass is at lowest point, right? Okay, so the string will break, right? The wire will break when the tension is maximum. Tension exceeds the value, okay, which the wire can sustain, right? It will break at that point. So when the mass is at lowest point, it will break. Most likely, okay, it is most likely to break when the mass is at lowest point. Again, this was also straightforward. Right? Is there a question? Is there a doubt in this? Okay. The next one. A body initially at rest and sliding along frictionless track from a height h, as shown in the figure, just completes a vertical circle of diameter AB equals to D. So this is the body. It is sliding from this point and it completes vertical circle of diameter AB equals to D. The height h is equal to. So what should we do? We want to find this height in terms of d. What should we do? So this is simple. See, in order to complete this vertical circle, okay, in order to complete this vertical circle, it must enter this loop with minimum velocity which is required to complete the vertical circular motion, right? But it is entering at this point, it is entering at bottom. So how much is the minimum velocity at bottom? Square root of 5gr. So it must enter this bottom point with this velocity, square root of 5gr, right? Okay. Then it is very simple. The potential energy at this point gets converted to kinetic energy at this point. Okay, so potential energy at top, I can say at top, let's suppose it has only potential energy, and at the bottom, at this point, it has only kinetic energy. So potential energy at top, or we can say sum of potential energy. Let's call this point C. So potential energy at C, okay, U at C plus kinetic energy at C is equal to U at A plus kinetic energy at A. So it is released from this point. So it has no kinetic energy. This is 0. Okay, Kc is equal to 0 because it is just released. Then you can take UA on left hand side, potential energy at A at left hand side. Okay, so what do you get? Kinetic energy at A is U at C minus U at A, which is mg h at C minus h at A. So which is height difference between these 2 points, and which is equal to what? H. So this is equal to mgh. Okay. And kinetic energy at A is half of m into Va square. So this is equal to mgh. So m and m gets cancelled. And how much is the kinetic energy? So it is, sorry, how much is the velocity? Square root of 5gr. So its square is 5gr. Okay. So which implies that 5gr upon 2 is equal to g times h. So g and g also gets cancelled. So you get 5r upon 2 is equal to h, and you can multiply and divide by 2 because you want h in terms of d. So if you multiply and divide by 2, what do you get? So h is equal to 5 times 2r upon 2, or 2 times 2, right? You are multiplying and dividing by 2. So 2r is d, okay? So you get 5d upon 4. This is the answer, right? Okay, but when in exam, don't do all of this, right? In exam, you will just say potential energy here gets converted to kinetic energy here. Okay, so mgh is equal to half of m into Va square, and Va equals to square root of 5gr. Cancelled, okay, gg cancelled there itself, right? You don't have time to do this, all of this. Yes, no? Okay, right. So this was also a simple problem. Let's see this one. As shown in the figure, a mass is performing vertical circular motion. The average velocity of particle is increased. Then at which point will the string break? Repeated question. Okay, answer is option B, right? So when was the earlier? Okay, that was earlier. 2019 it got repeated. Okay, next question. A child is sitting on a swing. Its minimum and maximum heights from ground are these: 0.75 meters and 2 meters respectively. Its maximum speed will be. So this is simple. Okay. So its maximum speed will be how much? So you can say half of m into v square. Whatever is its speed, maximum speed, it's equal to mg, the difference between heights at these 2 points. So let's call this one A, this one B. Okay, so mg hb minus mg ha. Okay, and you can take mg common, so it is hb minus ha, right? Understood or not? Okay, so then m will get cancelled. Take 2 on other side. So v square is equal to 2g multiplied by hb minus ha. So how much is hb? 2 minus ha 0.75, and then this will be 1.25, right? 1.25 times 2, 2 times 10 multiplied by 1.25. So 1.25 times 2, 2.5, 2.5 times 10, 25, and it is v square. So v is equal to 5 meters per second. 5 meters per second is the answer. Option B. A stone is tied to a string of length L and is whirled in a vertical circle with the other end of the string as the center. It will be at the center. At a certain instant of time, the stone is at its lowest position and has speed u. Okay, so at lowest position, the speed is u, right? So at lowest position here, okay, the speed is u. Then the magnitude of change in velocity, the magnitude of change in velocity as it reaches a position where the string is horizontal. Okay, that is here, right? G being the acceleration due to gravity is. All right. So this is little bit tricky question compared to the all the previous questions. Okay. So they are asking what is magnitude of change in velocity. So velocity at this point is directed like this. Let's call it u bar. Okay, it will have some magnitude. Velocity at this point, okay, let's suppose it is moving like this. It is moving like this. So at this point, it will be directed like this. It will have some magnitude, right? It will have some magnitude. So let's call this magnitude as v. Okay. So what is change in velocity? Let's call this one u bar and this one as v bar. So what is change in velocity? So for that, this is your initial vector u bar and this is the final vector. Okay, and you want to subtract this one, this is v bar, this is u bar. You want to subtract this one from this one. So you can draw its negative vector, right? You can draw its negative vector, which will be directed like this, let's say. Okay, so this is minus v bar, and then you can add them. This is minus v bar, and then you can add them. So u bar plus minus v bar, okay, will give you this vector. And they are asking what is the magnitude of change in velocity. Okay, so you can find change in velocity and you want magnitude of that. So you want magnitude of this vector. Okay, so this is u bar minus v bar, sorry, minus v bar, but you don't want, I mean, you want magnitude of this. So how much would be the magnitude? It will be u square plus v square, right? Use the triangle law. Magnitude of this vector will be what? Sorry, square of magnitude will be u square plus v square. Yes or no? Yes, Tamil Selvi, understood or not? Okay, good. So, square of magnitude of this vector, you want change in velocity, magnitude of change in velocity. So, you can say u bar minus v bar, magnitude of that square is equal to u square plus v square. So, this is u that you know, but how much is magnitude of v? That we can find out. Okay, that we can find out. How come? So, using the law of conservation of energy, right? So this much height, okay, this much height is equal to what? Length of string. Okay, so when the string goes from here to here, okay, so sum of its potential energy gets converted to what? Kinetic energy, right? So potential energy plus kinetic energy at this position is equal to kinetic energy at this position. Okay, so we can say that half of m into u square is equal to half of m into v square, okay, that is at this position, plus mgh, okay, that is mgl. Can we say this? See, when, let's suppose there is this stone, okay, it goes from this height to this height, it loses its potential energy and part of that potential energy gets converted to kinetic energy. So let's suppose it has zero potential energy at this point. Okay, let's suppose it has zero potential energy at this point. Okay, so its kinetic energy at this point is equal to what? Sum of potential energy and kinetic energy at this point, right? So I can say half of m into u square is equal to half of m into v square plus mgl, right? Okay, so then gets cancelled, m gets cancelled, and you want v square. Okay, you want v square, so take that gl on other side or multiply whole equation with 2. So what do you get? You get u square equals to v square plus 2gl, and that means v square is equal to u square minus 2gl. Okay, v square is u square minus 2gl, and put that here, right? Okay, so v square is u square minus 2gl. Let's put that here. So you get, okay, whatever is change in magnitude square, that is equal to, this thing is equal to what? U square plus u square minus 2gl. So I have substituted in place of v square, u square minus 2gl. Okay, then u square plus u square will give you what? 2u square. Okay, 2u square minus 2gl. Then you can take 2 common, and you want only magnitude, not magnitude square. Okay, this is change in velocities, magnitude square. You want only the magnitude of u bar minus v bar. U bar minus v bar. So it will be square root of right hand side. So square root of 2u square minus 2gl, or you can take 2 common, u square minus gl. So this is the answer. Okay, so this is the answer. Option A is the answer. Is it clear? So now next we will solve questions based upon the spring block system. Okay, so we had covered the theory of spring block system in the earlier lecture, in yesterday's lecture, right? In yesterday's lecture. So let us solve the questions. Okay, so two springs A and B having spring constant Ka and Kb. So Ka is equal to 2 times Kb are stretched by applying a force of equal magnitude. So there are two springs A and B. Okay, so this is spring A, this is spring B, and you are exerting same force on these two springs. So same force, F and F, right? So question is, if energy stored in spring A is Ea, then energy stored in the spring B will be. Okay, so spring constants are given. K is equal to 2 times Kb. So forces are equal. Okay, forces are equal. See, question is two springs A and B have spring constant Ka and Kb. K equals to 2 times Kb. Okay, they are stretched by applying a force of equal magnitude. So force is equal. Okay, if energy stored in spring A is Ea, then energy stored in the spring B will be. Okay, see, so force, the spring force is minus of K into X in magnitude, right? So now energy stored, we have this formula, half of K into X square. So because force is equal, I will manage force in this formula. Okay, I am given with K, right? I am not given with X. Okay, X is not given. So what I will do is I will multiply with K, so that this becomes K square X square, and I will divide by K. Okay, so this becomes half of Kx square, which is 4 square, F square, right? F square divided by K. This is my formula for energy. Okay, so force is constant, right? Force is same on A as well as B, spring A as well as spring B. So you can write that energy is inversely proportional to K. So EB upon EA will be equal to what? It is inversely proportional. So it is Ka upon Kb. And you want energy of B. Okay. And K is equal to what? 2 times Kb. So this is 2 times Kb. So 2 times Kb upon Kb. Kb cancelled. So EB is equal to, take that EA on other side. So it is 2 times EA. So this is the answer. Now is it clear? So let us see next problem. So this is from NEET 2003. When a long spring is stretched by 2 cm, its potential energy is U. If the spring is stretched by 10 cm, the potential energy stored in it will be. So this is very simple. What is potential energy? U is equal to, or let's call it U1. U1 equals to half of K times x1 square. And U2 will be equal to what? So U2 will be equal to half of K times x2 square. Okay, so this half K and half K, if you divide, half K and half K gets cancelled. It is x2 upon x1 square, right? U2 upon U1 will be x2 upon x1 square. So how much is x2? Okay, it is 10 centimeters. X1 is 5 centimeters. So you get U2 equals to 10 by 2 square. X1 is 2 centimeters. Okay, 10 by 2 square. Okay, times U1. So it is 5 square, 25 times U1. This is the answer. Next question. A mass of 0.5 kg moving with a speed of 1.5 meters per second. So this mass, it's moving with a speed of 1.5 meters per second on a horizontal smooth surface. So this is horizontal smooth surface. Okay, so its speed will not change. Collides with a nearly weightless spring, collides with the spring, okay, of force constant K equals to this thing, 50 newtons per meter. The maximum compression of spring would be. So tell me, what will happen? So this mass will collide with that spring. The spring will get compressed. Okay, and now this mass is doing some work on spring because it is compressing the spring. Okay, so its energy slowly and slowly gets converted to what? It gets converted to the potential energy of the spring, right? So it is losing the kinetic energy, and that kinetic energy gets converted to potential energy of spring. So there will be one point where that mass will stop. When will it stop? When its total kinetic energy gets converted to the potential energy of the spring. Okay, so it's simple then. The maximum compression will be when the I'm sorry, it will be when the total kinetic energy of this mass, which is half of mv square, gets converted to the potential energy. So half of k into x square, right? So half and half gets cancelled, and you want to find out the maximum compression. So x is what you have to find out. So x square equals to mv square divided by k, and that means x is equal to m upon k square root of this multiplied by v. So that is, how much is m? It is 0.5, right? 0.5 divided by k is 50 multiplied by v is 1.5. So 0.5 divided by 50. Okay, so it is what? 1 upon 100, right? If you multiply and divide by 2. So if you multiply this by 2, this will be 1, this will be 100. So it is 1 upon 100. Square root of that is 1 upon 10. So 1.5 divided by 10 is how much? 0.15. So 0.15 meters is the answer. The potential energy of a long spring when stretched by 2 centimeters is U. If the spring is stretched by 8 centimeter, the potential energy stored in it is. You tell me. Very good. Option D. Right? This is straightforward. Okay. Everybody? Okay. So this is option D. And they have repeated this question. Okay. 2006 and 2003. Okay. Next question. A vertical spring with force constant K is sorry, a vertical spring with force constant K is fixed on a table. A ball of mass m at height h above the free upper end of the spring falls vertically on the spring so that the spring is compressed by distance d. The net work done in the process is. This is the question. Okay, so this is simple. See, there is this vertical spring fixed on a table. Okay, and there is a mass which falls from some height h. Okay, it's given that it falls from this much height, h, and then the spring gets compressed. So compression in the spring is suppose this much. Okay, suppose it is this much. It's given to be d. So how much is the total work done? So what will be total work done? One is the work done on this mass, okay, due to the gravity, you can say, right? It is mgh plus d, okay, and work done on the spring is how much? Half of k into d square. So which is the answer? See, okay, you can see it in this way, okay. So now that mass, it is losing its potential energy. Yes, no? Let's find out total change in potential energy. Okay, total change in potential energy. So this mass, okay, it is losing the potential energy, right? So its change in potential energy will be minus of mg multiplied by change in height, h plus d, okay. And the spring is gaining the potential energy because the work is done always against the spring force, okay. So spring is gaining the potential energy, so change in its potential energy is half of k times x square, and the work done will be what? Opposite to the change in potential energy. Opposite meaning negative of change in potential energy. So tell me, work done will be equal to what? Minus of change in potential energy. So that is mgh plus d minus half of k times x square. So option A is the answer. Got it? The explanation. Okay, why this negative sign? Why not positive? Right? This is conceptual point, right? The mass is losing its potential energy, the spring is gaining. So change in potential energy of the mass is negative. Okay, change in potential energy of spring is positive. Okay, and work done is equal to what? Negative of the total change in potential energy. And that's why we have mgh plus d minus half of k into x square. Right? So yes. Let's see next question. A block of mass m is attached to the lower end of a vertical spring. Okay, there is vertical spring like this, and you attach a mass m. Okay, and then the spring is hung from a ceiling. So spring is hung from a ceiling. Okay, and it has force constant value k. The mass is released from rest with the spring initially unstretched. The spring is initially unstretched. Okay, the maximum extension produced in the length of spring will be, what will be the maximum extension produced in the length of the spring? Okay, who can tell? All right, see what will happen. You release that mass. Okay, so the spring is unstretched initially. So now the mass is connected to the spring. If you release it, there will be some extension in the spring. So when there is an extension, what happens? The potential energy of mass increases or decreases? The potential energy of mass decreases, right? And it is equal to increment in the potential energy of the spring. So can I say this? Okay, the potential energy of mass will decrease because it is falling down, so its height will decrease. Okay, but spring is getting stretched, so its potential energy will increase because there will be work done against the spring force. So this is mgh, suppose, is the decrement in the potential energy of the mass. So it is equal to, okay, or let's call it, instead of h, let's call it x only. Okay, right? So mgx is the decrement in potential energy of mass. So increment in potential energy of spring is half of k times x square. So x and x gets cancelled out. Okay, so then you take that 2k on other side. So you get x equals to 2 times mg divided by k. This is the answer. Which option? Option A. Okay, this is the answer. So next question. Two similar springs P and Q have spring constants Kp and Kq such that Kp is greater than Kq. They are stretched first by same amount, okay, then by same force, case B. The work done by the springs Wp and Wq are related as in case A and case B respectively. So when they are stretched by same amount, we can say work done is equal to what? Half of k multiplied by x square. This is the relation. Okay, and when they are stretched by same force, we have just found that for same force work done, we can write it as half of k square x square upon k, right? So we will multiply and divide by k such that numerator is what? Force square, because kx is the force. So it is f square upon 2k, right? So in first case, we'll use this formula. In second case, we'll use this formula. So which is the answer? So Kp is greater than Kq. Okay. So Wp upon Wq is equal to, so half of Kp times x square upon half of Kq times x square. So when they are stretched with equal distance, right, same amount. So Kp is greater than Kq, that means Wp will be greater than Wq, right? Wp is to Wq is Kp is to Kq. So Wp will be greater than Wq, right? And in second case, what will happen? So it's inversely proportional to K when they are stretched by same force. So in second case, Wq will be greater than Wp, because work done is inversely proportional to K. If K is more, then work done will be less. If K is less, work done will be more. So Kp is greater than Kq. So work done on Q will be greater than work done on P. Wq will be greater than Wp. Okay. So yeah, Sanjay is saying option A. Is it the option A? Wp is greater than W. Right. Option A is the answer. Next question. A spring with force constant K is initially stretched by x1. If it is further stretched by x2, then the increase in its potential energy is, this is the question. So initially it is stretched by x1, then it is further stretched by x2. Okay, so what will be total stretching? X1 plus x2, right? So final potential energy can be written as what? Half of k multiplied by total stretching x1 plus x2 square. This is suppose u2. Okay, and u1 can be written as half of k multiplied by x1 square, right? So increase in its potential energy when it is further stretched by x2. Okay, that's what we have to find out. So it will be equal to u2 minus u1, right? It will be equal to u2 minus u1, and that's equal to, so for that we have to expand this square. Okay, half k we can take common, then it will be x1 square plus 2 times x1 into x2 plus x2 square minus x1 square. So this x1 square and x1 square gets cancelled, and then we are left with half k multiplied by the remaining thing. So yeah, we can take x2 common. So it is half k multiplied by x2 multiplied by 2x1 plus x2. So option B, it seems. Okay, option B is the answer. Next, let us see when there is some loss. Okay, so when there is some loss in energy, how to solve the problem. Okay, so problem is a body of mass 1 kg is thrown upwards with a velocity of 20 meters per second. It momentarily comes to rest after attaining a height of 18 meters. How much energy is lost due to air friction? This is the question. So see, it has some velocity 20 meters per second. Okay, so its kinetic energy gets converted to what? Potential energy. When it attains some height, the kinetic energy gets converted to potential energy. So P at height H, you can say, plus there is some loss. Okay, and that's what we have to find out. How much is the lost energy? Okay, so loss, okay, or lost energy, that's what we want to find out. Okay, so now kinetic energy is half of m into v square, and it is equal to potential energy at height h, so mg h. Okay, we want to find out lost energy, no? So let's take that potential energy on other side. So lost energy will be equal to kinetic energy, which is half of m into v square, minus potential energy, which is mgh. So what is its mass? 1 kg. So 1 multiplied by v square is 20 square, minus mgh. So m is 1, g is 10, h is what? 18. Okay, it attains the height of 18 meters, right? So how much is the energy loss due to the air friction? So this is equal to 20 square is 400. 400 divided by 2 is 200, minus this is 18 times 10 is 180. So 20 joules is the answer. Option D. Okay. So let's see next question, and you will tell me answer of this. 300 joule of work is done in sliding a 2 kg block up an inclined plane of height 10 meters. Work done against the friction is. Three hundred joule of work is done in sliding a 2 kg block up an inclined plane of height 10 meters. Okay, work done against the friction is. Tell me. See, 300 joule is total work done. I can say total work done when you move this block. Okay, 2 kg block from here to here. So there will be some work done against the gravity, right? Which is equal to what? mgh. So work done against gravity, which will change its potential energy. Okay, plus if there is some friction, then there will be some energy lost in friction. Okay, so work done against friction, right? Can we say this? It is change in potential energy of the block plus work done against the friction. So this is equal to 300 joules. Okay, this is given, And how much is change in potential energy? So it is 2 times, so it is mgh, right? This is mgh, okay, plus we want to find out work done against friction. Okay, mgh is what? 2 times g is 10 and height is 10, so 2 times 10 into 10, 100, so it is 200, plus work done against friction. Okay, so how much is work done against friction? Work done against friction is equal to 300 minus 200, that is 100 joules. Okay, straightforward and very simple question. Option C is the answer. A body of mass 1 kg begins to move under the action of a time dependent force F equals to this thing, okay, 2t into I cap plus 3t square into j cap newtons, where I cap and j cap are unit vectors along x and y axis. What power will be developed by the force at time t? Okay, so this is straightforward question. What power will get developed? So power is equal to what? The instantaneous power is force times velocity. Okay, force is a vector quantity, velocity is also a vector quantity. So it is dot product of force and velocity. Okay, so that means we have to find out the velocity. Okay, so this is the force, right? And mass is given. That means you can find out the acceleration. And since mass is just 1 kg, so acceleration, which is force upon mass, okay, and it's a vector, so it will be equal to what? 2t times I cap plus 3t square times j cap, and it begins to move under the action of this time dependent force. Means its initial velocity is what? Since it begins to move, that means its initial velocity is 0. Okay, so what will be final velocity? So v will be equal to c. You can write acceleration equals to dv by dt. Okay, and then you can take that dt on other side. So dv is equal to a dt, and if you integrate it from 0 to t, you get change in velocity. Okay, so this is v minus u, right, equals to integral of a dt from 0 to t. But initial sorry sorry the initial velocity is 0 because it begins to move, it's given. So u is 0, right? And v is a vector because, okay, v is a vector quantity, a is also a vector quantity. Okay, so u bar is 0. Okay, so v bar is equal to integral of a bar times dt, and you have found a bar 2t into I cap plus 3t square into j cap. Okay, so do the integral. So integral would be simple, right? So 2 times t, 2 you can take out, into I cap 2t dt into I cap plus 3 times t square dt into j cap, right? What will be the integral? So this is t square upon 2. This 2 gets cancelled. This is t cube upon 3, right? Integral of this is t cube upon 3. 3 and 3 gets cancelled. So what do you get? V bar equals to t square into I cap plus t cube into j cap. And then you multiply force with velocity. What do you get? 2 times t multiplied by t square, which is 2 times t cube into I cap plus 3 times t square multiplied by t cube. So it is 3 times t raised to 5 times j cap. Okay, this is the power. So, okay, these many watts. Okay, one thing I forgot to tell you, The unit of power is watts, right? And one more thing, I did a mistake here. I dot I is what? Is 1. J dot J is also 1, right? So what do you get? These many watts. This is the answer. Option B. So let's move on to the next question. So a particle of mass m is driven by a machine that delivers a constant power k watts. If the particle starts from rest, the force on the particle at time t is. This is the question. Okay. So we know that power is equal to what? Force multiplied by velocity, right? Power is equal to force multiplied by velocity. And what's given? That power is constant. And how much is the power? It's equal to k. Okay. So we know if uh, that force acts on the particle, okay, and it changes its velocity, okay, it changes its velocity. So there will be some change in kinetic energy, right? Okay. So work done here will be equal to what? Change in kinetic energy. So delta Ke, okay. So that is equal to half of m into v square minus half of m into u square. And the particle starts from rest. So this will be equal to 0, right? Initial kinetic energy will be equal to 0, okay. And the power can be written as what? Work done upon time. So what is work done? It is power multiplied by time. Okay, so this is power times time. And initial kinetic energy is 0. So this term is 0. And power is given to be k. So k times t is half of m into v square. Okay, this is what we got. And we want to find out what? We want to find out the force. Now it's simple. Okay, so from this we can find out velocity. Okay, so we get v square equals to 2kt upon m. Therefore v is equal to square root of 2kt upon m, right? And we can substitute this here. Okay, so force is equal to power divided by velocity. So what is power? Power is k divided by square root of 2kt upon m. Okay, this is the value of force. Which is the option? So we can simplify this. Okay, this k and the square root of k, it will get cancelled, right? I mean, the square root of k will remain there. And this square root of m is in denominator. You can take it to the numerator. Okay, so this will be equal to what? So square root of mk in the numerator and 2 in the denominator. We can take 1 by 2 out. Okay, it will be root of 2 actually, not 1 by 2, root of 2. And then t we can take out and it's in denominator. So in denominator it is t raised to half. So in numerator it is t raised to minus half, right? So which is the option? Option C, right? Okay, yes or no? All right, let's move on to the next question. One coolie takes 1 meter to raise a suitcase through a height of 2 meters. But the second coolie takes 30 seconds to raise the same suitcase to the same height. The powers of two coolies are in the ratio. You tell me. This is very simple. Second coolie takes half of the time. So that means second coolie is option, it has to be option D, no? Option D. Okay, second coolie does it in half of the time. So second coolie is twice as much powerful. Okay, option D is the answer. Right, Sanjay? All right. So this was the easiest question. Okay, it can't get easier than this. This is clear, no, everybody? Okay. Next question. A car of mass m starts from rest and accelerates so that the instantaneous power delivered to the car has a constant magnitude p naught. Okay. So again, it is constant power question. The instantaneous velocity of the car is proportional to. So it starts from rest. Okay. And we have seen this formula for the power. So power is equal to what? Rate of change of kinetic energy with respect to time. Okay. And we want the instantaneous velocity. Okay. So now since the power is constant. Okay. Since the power is constant, the instantaneous power and average power will be equal. So we can just say this is equal to change in kinetic energy, final kinetic energy minus initial kinetic energy divided by time, because the power is constant only. Okay, so you can move this time on the other side. Okay, so for work done is equal to what? It will be power multiplied by time. Okay, because power is just constant, so P equals to W upon T you can say, or W equals to P times T, which is equal to change in kinetic energy. Okay, and it is power is given to be P naught. So it is final kinetic energy minus initial kinetic energy, and it starts from rest, right? The object, the car, starts from rest. It's given. Okay, so initial kinetic energy is 0, right? Initial kinetic energy is 0, so this is equal to final kinetic energy only. So this is half of m into v square. So now you want velocity is proportional to what? Okay, so you can move this 2 and m on other side. So what do you get? So you get v square is equals to 2 times p naught times t divided by m, and then therefore v is equal to what? Square root of that. So 2 times p naught upon m. This is constant. Okay, and you have square root of t also. Okay, so t raised to half, or square root of t you can say. So which option? Option B, I guess. Option B is the answer. A body projected vertically from the earth reaches a height equal to Earth's radius before returning to the earth. The power exerted by the gravitational force is greatest at the highest position of the body at the instant just before the body hits the earth. It remains constant all through, and at the instant just after the body is projected. Which would be the answer? Now, this is, let's suppose, Earth, and there is some body projected from Earth. So we can say a rocket, okay, projected from Earth, right? So we know the formula for gravitational force. It is equal to g into mass of Earth multiplied by mass of rocket upon r square. This is the formula for the gravitational force between two bodies, right? G into mass of Earth multiplied by mass of rocket upon r square. So as the rocket goes away, what will happen? The force between the rocket and Earth will decrease, right? The force will decrease. Okay. So, and one more thing. So it is projected vertically upwards and it reaches to some height. So when it reaches to some height, what will happen? Its velocity will become what? 0. So its velocity is maximum when it is at the Earth's surface. Okay, and force is also maximum when it is at the Earth's surface. As distance increases, what happens? The velocity also decreases and force also decreases because it stops at some height. Okay, so the power is force multiplied by velocity. Okay, when will it be maximum? You're saying option C? No, it doesn't remain constant all through. When it is on the Earth's surface. Now, at the instant just after the body is projected, this is one option, and at the instant just before the body hits the Earth, this is another one. So, which of these two will be correct? B or D? Because it will hit with the same velocity also. Yes. So see, when it is projected, the velocity is upwards and force will be in downwards direction. Okay, and this is dot product. Okay, and when it comes back, so while the rocket comes back on the Earth, okay, its color will not change. Okay, so velocity is in this direction and force is also in this direction, right? Because Earth is always pulling it. Okay, so what will happen? So in this case, the product of dot product of force and velocity, it is F multiplied by B multiplied by cos of 180 degrees when it is projected upwards. When it reaches back, it will be F multiplied by V multiplied by cos of 0, and cos 0 is 1 and cos of 1 it is minus 1. So it is greatest when it comes back. Okay, because in that case power will be positive. Yes, no? Okay, so at the instant just before the body hits the earth, this is the answer. Everybody got it? Okay, good. Okay, good. So let us see next question. An engine pumps water through a hose pipe. Water passes through the pipe and leaves it with a velocity of 2 meters per second. The mass per unit length of water in the pipe is 100 kg per meter. What is the power of the engine? Okay, what will be power of the engine? So here velocity is given, right? Velocity is given. So this is suppose the hose. So water comes out of this hose, right? So it comes out with some velocity. So now power can be written as what? Half of mv square, change in kinetic energy with respect to time. Okay, half mv square divided by t. So what are we given? We are given the velocity. So v we know, and mass per unit length. Mass per unit length is what we know. Okay, time also we don't know. So mass per unit length. So this is, suppose length equals to 1 meter. Okay, this length is 1 meters. So mass in this much length is given. Okay, so how much is the velocity? So m upon L is given, right? M upon L, mass per unit length is given. Okay, so per 1 meter, how much mass is there? 100 kg. And how much is the velocity? It is 2 meters per second. So how much length of the water is coming out per second? 2 meters. right? 2 meters is coming out. Okay, so how much mass is coming out? So 1 meter contains how much mass? 100 kg. So 2 meter will contain how much mass? 200 kgs, right? So we can say m upon L is given. Okay, so m upon L multiplied by L, this will give us the mass. Okay, we can put it over here. So what do we get? We get power equals to half of m upon L, mass per unit length is given, multiplied by L into v square upon T. And what is L upon T? It's the velocity, right? The length covered, okay, divided by time taken. It's the velocity. So this is equal to half of m upon L multiplied by velocity into velocity square. So it is velocity cube. So this is equal to half of m upon L is 100 multiplied by v cube. We have v is 2. We have 2 raised to 3, which is 8. 8 upon 2 is 4. 4 times 100, 400 joules. Sorry, what joules? This is power. So 400 watts is the answer. Okay. So option A. A particle of mass m starting from rest undergoes uniform acceleration. If the speed acquired in time t is v, the power delivered to the particle is. This is very simple. So speed acquired, yeah, option D. Very good. Option D will be the answer, right? Starts from rest. Okay, so how much is change in kinetic energy? Final minus initial. Initial is 0 divided by time. So this is the power. Power is change in kinetic energy divided by time. So final is half of m into v square, right? So this is the answer. Okay, final kinetic energy is half of mv square. Initial is 0. So final minus initial upon time is the power. So this is the answer. Straightforward. Okay, good Sanjay. Got it, everybody? Yeah. So this was second simplest question, you can say. Okay, first one was that, the coolie question, right? That one or other one? That one only, no? Yeah, that one was simplest. Okay, next question. Water falls from a height of 60 meter at the rate of 15 kg per second to operate a turbine. The losses due to frictional forces are 10% of energy. How much power is generated by the turbine? This is the question. Okay, so there is some loss. Okay, so how much power is generated is the question. Water falls from a height of 60 meters at the rate of 15 kgs per second. Okay, so it falls from height. mgh is its potential energy. Okay, and per second, how much potential energy is delivered? So we can divide it by time. So this is the input power, you can say. Okay, and since there is 10% loss, that means how much power would be delivered? So power delivered, okay, to the turbine, P will be equal to input power multiplied by 90% because 10% is lost. Okay, so 90 upon 100. So mgh, so you are given m by t, okay, is 15 kgs per second, right? It falls at the rate of 15 kgs per second. That means you are given with m by t. Then you can substitute the values. So m by t, this is 15, g is 10, and h 60. Okay, so it is 15 times 10 times 60 multiplied by 90% or 0.9 you can say. So how much is it? 15 times 6 is 90. Okay, 909,000 multiplied by 0.9. Okay, 9 nines are 81. So 8,100 watt, or you can say 8.1 kilowatt. This is the answer. Option C. Okay, this question. Tell me, you can solve this. Very straightforward. If force is this, velocity is this, instantaneous power is. Okay, third simplest question we can say. So it is just equal to what? F bar dot V bar, the dot product. Okay, so it is 60 times 2, 60 times 2 plus 15 times minus 4 plus minus 3 times 5. How much? 120 minus 15 times 4 is 60 minus 15. Okay, so 60 minus 15, 45. 45 is the answer. Okay, option B. Yes, very good, Sanjay. So how much water a pump of 2 kilowatt can raise in 1 minute to a height of 10 meters? This is the question. Okay, so 2 kilowatt is the power. So power is equal to, you can say, mgh upon T. So mgh is equal to power times T. So mass is equal to what? P times T upon gh, right? And now we can substitute values. So power is 2 kilowatt. That means 2000. Okay, multiplied by time. Time is how much? 1 minute. So 60 seconds divided by gh. So gh is, g is 10, h is 10. So this thing and two zeros gets cancelled. 200 times 6, 1200. Okay, 1200 kg is the mass. Okay, and answers are given in liters. So see, mass can be written as density multiplied by volume, and density of water is 1 kg per liter. Okay, so density is 1 kg per liter for water. Okay, so therefore volume would be equal to what? 1200 liters. So that's the answer, option B.